Okay, so today on Mr. J's or Professor J's Algebra Cafe, we're going to learn about section 2.2, the slope of a line. The first thing we want to review is what slope means. So slope is rise over run, change in y over change in x, or my favorite, delta y over delta x. And the way we use slope is if you are given a point, or if you find a point on a line, or if you have a line and you'd like to find the point, you'd like to find the slope by using 2 points, you would count up, that would be the change in y, and across or over, and that would be the change in x. And you can also graph a line like that. We are going to do that momentarily. Okay, so find the slope of a line passing through the following 2 points. What's nice about this problem is we don't have to actually graph this one. Although if we did, we would just graph the 2 points and there we go. So change in y over change in x. Once you've done this enough times, you can kind of just stop with the labeling. But for the first so many 100 times, I would suggest labeling. So if we want this one to be, y1. All right, I guess we want it to go first. So if the formula says y2, then this will be y1, x2, x1. So we want 5 minus a -6 over -3 minus 2. Those minuses are coming from the formula, the ones outside. So you always have to bring in your own signs from the points. 5 minus -6 will give us a positive, so that would be 5 plus 6, so that will be 11 when we get to it. I'll do it in a couple of steps. And then -3 minus 2 will give us a -5 on the bottom. So your slope for this one will be -11/5. Okay. We want to find the slope of a line and we're given that line in standard form. We want to make that form look like slope intercept form, which is y equals mx plus b. So we're going to subtract 3x to the right. So we have minus 7y equals -3x plus 21. And then going to divide all parts by -7. So y is equal to negative over negative gives us positive, so 3/7 x. And then positive over negative gives us negative, so -3. That is your equation, but your answer was to find slope. So you want to pull it out. 3/7. Okay. All right. So now we're going to find the slopes of some lines, but I threw on the coordinate plane here because I think it's good for us to do some graphing and then you can kind of see why those slopes are what they are. So for the first one, we're looking at x equal to 4. So we want to come here to when x equals 4. And x equals 4 is going to have an undefined slope because if you look, anytime we have x equal to a number, we're just going to go straight up that vertical line. And I apologize. I'm not using a pen, I'm using a mouse. So it makes it a little bit harder for me to go straight where I want to go. Okay, That's the best I can kind of do for you guys right now. You're going to go straight up and down on the x equal to 4. It'll always be a vertical line, and the slope will be undefined. Okay, and the rationale behind that is because if we do the change in y over the change in x, the x's will always be 4. So you're always going to have something over 4 minus 4, or in this case, it'll be the change in y is going to be whatever, and then the change in x is always going to be 0. Well, you can't have 0 on the bottom of a fraction, so it will always be undefined. Okay, now for b, and they make us solve it, of course, so we're going to add 6 to the other side, so y equal to 6. And then you're going to come here to the 6. It's going to be a horizontal line. Guess I did that one a little bit better. And it's going to be y equals 6 there. And similarly, you're going to have a change in y over a change in x. The x's will be whatever, but the y's are always going to be 6's. So you'll have 6 minus 6 over the change in x. You're not going to have a 0 on the bottom, so you'll have your 0 on top. And so then the slope will always just be 0 for if you have a y equals. Okay. Remember, you can always pause the video and take your own notes, or you can rewind it. Okay. All right, so for number 4, we just want to find the slope again. And again, they give it to us in standard form, and we want to put it into y equals x plus b. So we're going to subtract 5x to both sides. 12 minus 4y equals negative 5x plus 7. We're going to divide by negative 4. So your line would be 5/4 x minus 7/4. But your slope in general for this problem is just 5/4. Okay. Next one. The next one says graph the line passing through the point negative 4, 1 that has a slope of negative 2/3. So this is your slope. So the first thing you want to do is go to negative 4 and the 1, and it's going to be really hard to see on here. So make sure you guys are following along and doing it on your own. Oh, I just graphed negative 4, negative 1. Sorry, we want negative 4, positive 1. Okay, then to use the slope like we were talking about in the beginning, we're going to count down 2, so down 1, 2, and then to the right 3, 1, 2, 3. So down is where I'm getting my negative in that case, because right is positive, and this point should be negative 1, negative 1. Obviously here we have negative 4, positive 1, but we can also go up. If we go up 2, we'd be at 3, and then to the left 3, we'll be at negative 7. So that'll be negative 7, 3. And then you would just draw out your line. Again, my drawing is not going to be the best. Okay, so that's how we use slope. Okay. Okay, so this slide just kind of helps you figure out a little bit about the different kinds of slopes. You can have positive slope, which for this case, if you wrote the general equation, you're going to be looking at y equals positive ax minus b, because your y-intercept is below the x-axis. For the next one, you're looking at a general equation of y equals negative ax plus b, because it's above the line. And then remember that when we have the special cases, you're going to have y equal to a when it's horizontal. And then you're going to have x equal to a when it's vertical. Okay. All right. Again, you can pause that last slide if you need a little bit longer of a time with it. So what we're going to do here is we're going to look at two different lines. The first line has the 0.25 and 48. So let's find that slope. We'll say slope of line, or you could say L1. So that would be slope 1, which is going to be the change in y over the change in x. So we have 8 minus 5 over 4 minus 2, which gives us 3/2, or 3 over 2. And then we're going to have the slope of line 2, or L2. So we're going to have slope 2. Again, change in y over change in x. In this time, we can do 0 minus a negative 2 over 2 minus a negative 1. Negative negative gives us a positive, so that'll be 2. And negative negative gives us a positive, so that'll be 2 plus 1, which is 3. To have parallel lines, we have to have the same slopes. And here you can see that we actually don't. We have reciprocal slopes, but they're not the same slope. So you would conclude this as, therefore, not parallel. Okay. All right. I think I was just going to show you the, I can real quick. It won't be pretty, but we'll go ahead and do it. So if we're going to have 2, 5, and then 4, 8, that's going to be one line. That's line 1. And then we also have 2, 0. And then we have negative 1, negative 2. Okay. You guys can see that is those are intersecting lines. They are not parallel. Okay. So for this situation, you're looking at two examples. One or either of them could either be parallel, perpendicular, or neither. Okay, let me get that out of the way. Okay, and I think we have, nope, we only have one of these. So let me try to write as small as possible. So for A, we need to rearrange both of those. So let's do 2y equals negative x plus 7. You guys can see that all I did is I moved the x over. Okay, so then let's divide now by 2. So we would have y is negative 1/2 x plus 7/2. So the first slope for A is 1/2. And then the second equation, we just have to add 4 to the other side. Do you guys see that? If we add 4 and we add 4, then it gets the y by itself. So that would be y equals 2x plus 4. So our second slope is 2. And sorry, this should be a negative. So slope of the first line was negative 1/2, and slope of the second line is technically 2/1, and it's positive. So A is in fact perpendicular. Perpendicular. You can also use the symbol, which is an upside down T. B. Let's move the 2x from here. And here we just move the x, just so you guys, if you need it, you can see it. So for the, and then for this one, I'm gonna swap places with the 4 and the y, and those will change signs, but so we're essentially subtracting 4 on both sides and adding y on both sides. I'm just doing this like this so you guys have enough room. Essentially, if you solve each piece for A, or sorry, not for A, for Y, you're going to be able to compare slopes. So let's do this one first. We're subtracting 4 and adding y. So it's going to be y, and then 2x minus 4. Yep. And then the other line will be y equals negative 2x plus 6. So you're looking at a slope equal to 2 and a slope equal to negative 2. So those are not parallel and those are not perpendicular, so they are neither. Okay. All right. So all this one is doing is it's showing you how to use slope in an application sense. So it's just the rate of change. So you're going to use 84 and 2013, and then we're going to use this from the example in the book. So you would have change in y over change in x. Your first point is 2017 and 95. So 2017, you can see the years are on the x's. Excuse me, minus 2013. And then on top will be 95 minus 84. So that's going to give you a slope of 11 over 4, which is 2.75 million subscribers per year. Okay, so on your test, if you have to write if you have the application problem, you have to write that kind of stuff. You can't just do 2.75. You have to do 2.75 what? 2.75 million subscribers per year. Okay. All right, so for this one, we're looking at 2011 goes with 33 billion euros. 2016 goes with 17 billion euros. So again, you're just going to have years are the bottom. So 2016 minus 2011, that'll give you 5 years on the bottom. And then 17 minus 33 will give you negative 16 on top. So that's going to give you negative 3.2 billion euros. I guess technically per year. Okay. All right, I will see everybody back for the recording on section 2.3 and probably 2.4 together. We'll see. All right, thank you. See you then. Okay, welcome back for section 2.3, where we are going to learn how to do writing equations of lines. So I mentioned last time that we have a form called slope-intercept form. I often call it y equals mx plus b. And we're going to work with that a little bit this section. So here you can see in this example, we're given the slope as 2/3 and the y-intercept is the b part right here, which is 1. So if we plug it into our equation, we're literally looking at y equals 2/3. Here, I'll even color code it for you, for everybody. We're looking at 2/3 x for the slope plus 1. Okay, that's it. If you don't like it color coded, I can also write it that way. Just be y equals 2/3 x plus 1. Okay. All right. So that's how nice it is whenever they give you both the slope and the y-intercept. Next, they want us to graph the line using its slope and y-intercept. So right now it's in standard form. We have to actually write it in this slope-intercept form to be able to nicely get the slope and the y-intercept. You can obviously solve this a couple of different ways. We've done it in the past where you find your x and y intercepts, but we want to kind of practice right now with the method they are suggesting. You can always check your work though using another method that you like. So if you like the finding that x and y intercepts, you can do that. So our slope here is going to be negative 4/3. And our y-intercept point is going to be 0, 2. So let's come in here. We go to 0, 2. All right. And then we're going to use our slope. So we're going to go down 4 and to the right 3. Okay. We could also go up 4 and to the left 3. And if I had pencil and paper and not a computer mouse, yeah, you guys can see how bad that was. But you get the idea. I promise I'm going to get something a little bit better. And remember, you always want to write it with the original line. So 4x plus 3y equal to 6. But you guys get the idea. Clearly, the line should be going through the point. Okay. Point slope form, literally, you want to use it for what it sounds when you have a point that is not the y-intercept and the slope. So in this case, what we're going to do is we're going to plug it in, and then we actually have to do a couple of steps to finalize it. So here we're given the slope negative 1/5. So slope equals negative 1/5. And we're given a point 5, -3. So we're going to go y. This y is from the formula and it stays minus a -3. See, we have a negative in the in the formula. And then we also have a negative for our given y. So it has to be negative. So we're going to change that in a minute. Then your slope x, this x is from your formula. It's not going to change. Minus 5. We're going to distribute and simplify. So negative again is going to give us a plus 3. Negative 1/5 x. Negative 1/5 times negative 5. The 5s are going to cancel out. And you're going to have negative. So that's going to just give you a plus 1. And now we just have to subtract 3 on both sides. So your overall answer is y equals negative 1/5 x minus 2. Okay. So now you've written that equation using this point slope form. In most cases, if you get it to y slope intercept form, that y equals mx plus b, then everybody's happy. Okay, so here what we want to do is we want to find the slope and then use this point slope form to get it into something we can work with. And then once we're done with that, we want to rearrange it to be standard form. Remember, standard form is when we have ax plus by equals c. Not 6 equals c. Can be anything. That was just the mouse deciding to do whatever it wanted to do. Okay, so let's take a look at this. Here's our slope. Okay, remember it's going to be the change in y over the change in x. Negative, let's start with the 1. So negative 1 minus a -4. And then negative 2 minus 3. It's going to give us a -4, so positive 4. So 4 minus 1 is 3. And then -2 minus 3 is -5. So our slope is still -3/5. But now we have a point and a slope. And so we're going to use our other form. We're going to use y minus y1 equals slope x minus x1. And we're going to plug in for it. So y minus a -1 equals -3/5 x minus a -2. So that's going to give you y plus 1, right? Because we have negative there. And before I distribute, I'm going to do x plus 2 here because negative. Then I want to distribute and simplify. So y plus 1, -3/5 x. And then when you multiply, you want to multiply the tops and the bottoms. So that's going to be -6/5 Now, I'm going to subtract 1 here, but I'm going to write it differently over here. 1 is the same as 6, sorry, not 6. 1 is the same as 5 over 5. And that's going to help us. So recall over here, -1 is the same as -5 over 5. Okay, and that's just going to help us out. So we're going to have y equals -3/5 x minus 6 minus 5 will give us a -11 over 5. And what I'm going to do is, if you see in your standard form, we don't have fractions, we have nice numbers. So before we move anything around, we're going to multiply everything by 5. Okay, and I'm also going to move this at the same time. If I'm moving it over, it's going to go from plus to positive. So 5 times 3/5 will give us just 3x plus 5y. And then the -11 stays on that side and the 5's cancel. So equals -11. Okay. You guys might have to watch that one a couple times to get every step. I guess I can get rid of this because I didn't end up using it. Okay. So example 5. Write an equation of a line passing through the point 4, -4, and the satisfying given condition. So this one is a lot nicer compared to the last one. If we're looking at these 2 points at this point, we have 4 and -4. Our x component is x equals 4. Our y component is y equals -4. This is an undefined equation. And this is a zero slope equation. That's it. That's how easy that one is. So hopefully you guys think the same. Okay. All right. So this one I definitely need an exercise. Cool. All right, we're going to write an equation of a line that passes through this point and satisfying the given condition. And then we want the final form to be y equals mx plus b. All right, so what we're going to realize is we only have to find the slope one time because this line and this line are the same. So let's find the slope first. Well, first we have to rewrite the equation. Oh, excuse me. So we're going to subtract 3x. We're going to have -5y equal to -3x plus 7. And we're going to divide by -5. So then your slope is -3 over -5, which is just 3/5. Your parallel slope is also going to be 3/5. And then when we get to it, our perpendicular slope will be the opposite reciprocal. So it's going to be not 3/5 anymore. It'll be negative, because right now we have positives, 5/3. Okay, so that's going to change what we're doing. Okay, right now we do not have the y-intercept, so we have to use the point slope form. So for A, we want to use the parallel slope. So, and then we want to use this point that we were given. So we will have y minus y1 equals slope parallel x minus x1. Okay, so I might actually be able to get this all into one. So we'll have y minus a negative 1 equals 3/5 x minus 6. We're going to distribute and simplify. So a negative negative gives us positive, so y plus 1. 3/5 x. Remember, we're just going to multiply the tops and the bottoms, so minus 18 over 5. Remember, we just recalled that we can do minus 1, and that's the same as minus 5 over 5. So our parallel line is going to be 3/5 x minus 18 and 5 give you 23/5. And if you graphed this line and you graph this line, you'll have a parallel set of lines. All right, let's do B. Now we're going to use, let's do B in blue. Okay. Now we're going to use our perpendicular slope and the same point. So we're going to have y minus y1 equals mx minus x1. Our slope changes now though. So we'll still have y minus negative 1, but now we'll have negative 5/3 x minus 6. We're going to distribute and simplify. So y plus 1, and then negative 5/3 x and then negative negative gives us a positive. And then remember, we're doing tops and bottoms, so 30 over 3. 30 over 3 is the same as saying plus 10. So we'll subtract 1. So your perpendicular line is going to be negative 5/3 x minus 9. There it is. And I can actually get rid of that. Okay. So you guys want to use this as a good summary of when to use the different forms. Slope-intercept form. Slope is m, y-intercept is the b part of the y-intercept when you have it in a point. The slope of y-intercept can be easily identified and used quickly to graph an equation. Point slope form, again, slope is m, line passing through any other point except for the y-intercept. This form is ideal for finding the equation of a line if the slope and a point are given on the line of, or 2 points of the line are given. Standard form, it has everything explained there. The x and y intercepts can be found quickly and used to graph the equation. The slope must be calculated. We have y equal to b, that's our horizontal line, so slope is 0. Again, you know the y-intercept. And then you have x equal to a, slope is undefined, x-intercept is a comma 0. 2 things to note here for the horizontal line. If the graph intersects only the y-axis, then y is the only variable in the equation. If the graph intersects only the x-axis, then x is the only variable in the equation. And you guys can definitely pause this if you want to write it down. Okay, let's look at this application problem. A cell phone plan costs $100 just for the phone, plus $85 per month of service. Write an equation that gives the cost Y in dollars for X months of the cell phone service plan. So Y is our function name. $85 per month. So 85 goes with the X. And we have a flat fee of $100. That's that one. Okay. Easy peasy there. All right. So for example 8, it says refer to example 8 in the book. That's why I pulled this part out. And it wants us for A to use the data values for the years 2012 and 2016. So I'm going to give those to you. That means for A, we're using the points 0, 3,216, and 4, 3,520. And that comes from a table in our book. But you don't really need it. It's just an example. So slope is going to be, remember, it's going to be the change in Y over change in X. So in this case, we're going to have 3,520 minus 3,216 over 4 minus 0. So here they replace the years with nicer numbers. Sometimes you can do that. You don't have to, because I mean, it's the same difference. 2016 minus 2012 is the same as 4 minus 0. You still get 4 out. 3,520 minus 3,216. You can verify me, but that gives you 304. When you divide that out, you get 76. So here's what's interesting. We needed to find the model, which is the equation. So to answer this question fully, we need to use our y-intercept and our slope. So our model is just going to be y equals 76x plus 3,216. Boom. All right, let's work on B. B says use the equation from part A, right here, to approximate the cost of tuition in 2005. So if 2016 was 4, 2005, we're going to write as 3. So that would just be y equals 76 times 3. We're getting that from 2015 plus 3,216. So your application answer would look something like this. When you do the math here, you end up with 228 plus the bigger number. And that's going to give you 3,444. But you want to type it out. So you want to say, or not type it out, you want to write it out. Therefore, which therefore can be those 3 dots that I like to use. They make a triangle. 3,444 is the tuition and fees approximated for 2015. All right, that's your answer for B. And you can do it like this. Therefore can be shortened to just that if you're handwriting it. Okay. Any questions on that stuff, you can email me. We do have one more example for application. I'm gonna go ahead and do it with you. So for A, again, we're looking for slope. They give us our two equations. We have to find slope first so we can write the model out. So we're gonna do 1,800 or not 1,082 minus 978 over 6 minus 4. We're going to get 104 over 2, which is 52. We were not given the y-intercept, so now we have to use point slope form. So y minus y1 equals x, nope, slope first, equals slope x minus x1. Let's try to squeeze it in here. Y minus, let's go with the bigger one. So 1,082 equal to 52 x minus 6. We're going to distribute and simplify. So y minus 1,082, 52x minus 312. We're going to add 1,082 to both sides. So your model here is y equals 52x plus 770. That's your model. Then for B, we're just going to throw in 2019, which if you look at that from the part B here, x equals 1 equals 2009. So then x equals 9 represents 2019, and that's what we're looking for is 2019. So we're going to use a 9. So that means y equals 52 times 9 plus 770. And that works out to 468 plus 770 is going to give us 1,238. So then if you write this out better, you're looking at, therefore, 1,238 billion in 2019 estimated hospital expenditures in the US. There. I think you guys can read that okay. And most of you should have been following along, so I think you're okay. All right. That is it for this section. So I will see everybody back in a few minutes for section 2.4. Thanks for joining me. Okay, so we are now going to dive into linear inequalities in two variables. This is section 2.4. It's the last section before your Unit 1 exam. So we're going to work on graphing inequalities in two variables. So the first thing we're going to do is we're going to treat this like a regular equation. And we're going to solve it for y something. It's not always going to be equal to, obviously, because we're going to have inequalities now. Okay, so what we're going to do first is we're going to graph this as if it were a normal equation. So we're going to go to 2 on the y, and then we'll use the slope. Up 1 into the right 2, up 1 into the right 2. Yep, up 1 into the right 2, right 2, up 1, right 2, down 1, right 2, down 1, left 2, sorry, down 1, left 2, down 1, left 2, down 1, left 2. Okay, so that is our general line there. And then what we have to realize next is if we're going to have a dashed or a solid line, to figure that out, you have to look at the inequality. As you guys can see here, there's an equal to part. Because there's that equal to part right there, that line, that equal to part, we're actually going to draw a line like normal. So it's probably my best line with a mouse. Good job. Woo! You can label that if you wish. I'm not going to, just because I need to also write in a test point here. So as you can see here, 0, 0 is pretty far away. And that's how I would write it on my test paper, is TP, test point. And then you want to come over here and actually use it. So test point. This is just a good way to know how to shade. You're always going to look at the original. So you're going to plug in 0 for x and 0 for y greater than or equal to 4. The zeros actually cancel everything out. So is 0 greater than or equal to 4? That is false. So we are actually going to shade. So when that's false, we are going to shade opposite the test point. Okay, so you're actually going to come in here, pick the color you want to shade, and you're going to shade this side of it. It's okay to leave that test point there. You told me it was your test point, so I'm not going to, wonder why it's there. You've told me why it's there. Okay. All right, so for example 2, same basic process. We're going to solve for y first. So we're going to subtract 3x. I'm going to drop off the 0 because it doesn't mean anything. Although I guess I'll leave it because that will help you guys see where your y-intercept is. So that's 0, 0. And then we're going to divide everything by a -2. Remember, when we divide by a negative or multiply by a negative, we're going to flip the orientation of our sign. So it was facing this way. Now, when we rewrite it, it'll be y greater than 3/2 x plus 0. So if we use our slope for the rest of our graph, it's going to be up 3 and to the right 2, up 3 and to the right 2, up 3 and to the right 2. And then we would be going off, so down 3 and to the right 2, or left 2, down 3 and to the left 2, down 3 and to the left 2. Okay, now what you can notice and what you should notice here is that we do not have an equal to part. So we are going to do a dashed line. Dashed lines I always liked more because then I felt like my professor would, like, they wouldn't be as strict on my artistic ability. Okay, and again, you can label this with the original, so 3x minus 2y less than 0. Okay. What we have to figure out now is our test point again. Remember, we are not going to pick 0, 0 because 0, 0 is on the line. So we have to pick a different one. So let's pick -2, 4. So -2, 4. That's our test point. Okay. We're going to plug it into the original. So 3 times -2 minus 2 times 4. Is that less than 0? Well, -6 minus 8. So is a negative number less than 0? So that would be -14. Is -14 less than 0? That is true. So we are going to shade it. So this is true. So we're going to shade with the test point. You can pick a whole bunch of test points. If you really think you messed up, you can always pick another one. You can pick one on the opposite side and that should come up false. So it's really up to how you want to do things. Oh no, I apologize. I did not mean to randomly hit that. This is what I meant to hit. Okay. So, heading towards the last set of examples, we're going to solve for this. So -2, -2. So we have x greater than -2. So we're going to come to -2 on the y, on the x, and then it's going to be a vertical line. It's also going to be a dashed vertical line, so we don't have to be as specific with it. You guys want to try and be, obviously it's harder for me to draw straight lines when I'm on a computer. And then you could use a test point here. You can also use the cheat that because our variable's on the left, you can just know that if it's facing the right, then you're going to shade to the right. You can verify that, obviously, by doing a test point. Even if we did a verbal test point, if you use 0, 0, 0 is greater than -2. That is a true statement, so we're shading this way. And that's it. That's it for this one. Now, what's very important about this case is that this is an and. So when we have an and, we're looking at inequalities that are involving an intersection of the solutions. So you must have true statements for both in order for you to shade the region. Now, what we've been looking at before, and you can see it clearly here, is we have region 1 and we have region 2. We can even label them if you like. So we have region 1. And the one we shaded was region 2. There's only 2 distinct regions when you have only one line or one inequality. When you have 2, you now will have 4 regions. So let's solve for the first one. We're going to subtract x on both sides. So it'll be y less than negative x plus 3 and y less than or equal to 2. So let's graph this first one. We're going to go to 3. And then we'll go up 1 and to the left 1. Up 1 and to the left 1. Up and to the left. Up and to the left. Up and to the left. It's going to fall along this diagonal. And then down and to the right. Down and to the right. Down and to the right. Again, it's falling along the same diagonal. Okay, you guys can see there's no equal to parts, so you are going to do a dashed line. Okay, and this is x plus y less than 3. And then we also want to come to where y is 2. So that's right here. Let's do it with a different color since I have them. It's right here. And we want to draw, it has an equal to part, so we're going to draw with a solid line. And that was kind of terrible. I apologize, guys. Doing the best I can with it. So y greater than or equal to 2. So in this case, we have to figure out in the 4 different regions. So region 1, it's going from here to here. And I'll try to use different colors so you guys can see it. Region 2. And region 3. Just realized I reused a color already, I'm sorry. And then the last one is region 4. Okay. So what you want to do is you want to pick a test point, and then you want to test it for both, and they have to be true for both. So again, I'm going to use the test point 0, 0 because it's definitely distinctive and it falls actually within this region 4. So test point. And then you just have to pick more test points if you need to. So if you don't pick a good one to start with, just pick another one. It just has to be in a different region. So is 0 less than or equal to 2? That is true. And you want to always look at the originals. So is 0 plus 0 less than 3? Is 0 less than 3? That is also true. So we're actually going to be shading region 4. And that just happened to work out that way. I just know everybody likes using 0, 0 as their test point. So it just kind of happened. With the next example, I'll go back a second so you guys can pause that if you need to. With the last example, you're looking at an intersection. Okay, so we want to solve for our inequality first. So negative 3x minus 3x. Then we'll have a minus 5y less than negative 3x plus 15. We're going to divide by a negative 5. When we divide by this negative 5, our inequality is going to flip. So let's just write that in a different color. So we'll have y, and now we're greater than 3/5 x minus 3. And then what you need to pick up on here is that we're dealing with an or situation. So that means we have a union. A better way to describe that is that now instead of having true for both situations, we just need to have a true statement for one of them, and then that region gets shaded. So we're basically going to have 3 out of the 4 regions shaded, and your job is to figure out which one doesn't get shaded. If you find that you have 2 false statements right away, then you have a pretty good bet that that's the region you don't shade, and you'll shade all the rest of them. You can obviously check them all. It would be my recommendation to do so until you've done enough of these that you don't really feel like you need to check anymore. So let's use the trick with the x greater than 4. So we're going to come to x equal to 4. And it is a dashed line. X greater than 4. Okay. Now, if this was by itself, we could just shade to the right and be done with it. But we don't know which ones we're shading yet. So let's do that. Let's shade, or let's do our other drawing and then we'll shade. So let's go to -3. And then we'll go up 3 and to the right 5. And we'll go up 3 and to the right 5. And we'll also go down 3 and to the right 5. And then down 3 and to the right 5. And again, it's dashed. And this is 3x minus 5y less than 15. Okay, hopefully you guys can see our regions here. We have region 1. Just call it R1. We have R2. R3. And I don't think I can use the white, so I'll reuse black, R4. Okay, and now we need a handful of test points. So we can still use 0, 0, and that puts us in region 1. So there's going to be a lot of test points. Okay, so 0, 0, and we can do some of them kind of verbally. Is 0 greater than 4? No, so that would be false. But now we also have to check the other one. So 3 times 0 minus 5 times 0 less than 15. Is 0 less than 15? That's true. So we're going to shade region 1. Okay. Now we need a test point for region 2. Let's use 5, 1 because that'll help us out. And you don't have to label all of them, but if they help you for labeling, that's fine. So 5, 1. We know 5 is greater than 4. Boom. That's all we need. 5 is greater than 4. So because that's true, we'll shade it. And I know it kind of seems like sneaky, but we can actually do the same thing on the other side. We could do 5, -1, and it's the same statement. 5 is greater than 4. Again, that's true. So we shave region 3. And now we've shaded 3 out of the 4 regions. So the assumption would be that region 4 should remain unshaded. So let's just prove that. Let's do like 0, -7. I'm going to write it in another color though. I'll write it in red over here. So 0, -7. So we have 0 greater than 4 is false. But we have to check the other one. So 0 times 3 will give us 0. -7 times -5 will give us a positive 35. Is 35 less than 15? No, that's false. So we do not shade region 4. And that, I believe, is our last question. I will be doing a Q&A this weekend to help you get ready for your Unit 1 exam, as well as we will be doing an in-class Unit 1 review. So I will see everyone at class. Have a great day, and thanks so much for stopping to watch my videos.